Theta notation. This notation decides whether the upper and lower bounds of a given function or algorithm are the same. So the average running time of an algorithm is always between the lower bound and the upper bound. If the upper bound O notation and the lower bound is omega notation give the same result, then the theta notation will also have the same rate of growth. Okay? So the rates of growth in the best case and the worst case are the same, like f of n equal 10n plus n. As a result, the average case will also be the same. For a given algorithm or function, if the rates of growth or the bounds for O and omega are not the same, then the rate of growth of the theta notation will not be the same. In this case, we need to consider all possible time complexities and take the average of those. So the average time is the theta notation. So if the upper and lower bound are the same, so average and the theta notation would be the same. If lower and upper bound are not the same, we took the average time of all algorithm between them and consider them as a theta notation. For example of this, we need to get f of n equal to n squared over 2 minus n over 2. Find the theta bound for the f of n. If we have here this function, we have two terms, the first one and the second one. We have n squared over 2 and minus n over 2. So this function is between less than or equal the n squared and it is about greater than or equal to n squared over 5. So for all n greater than 2, whatever n greater than 2. So n squared over 5 less than or equal n squared over 2 minus n over 2 less than or equal to n squared. In this case, the average notation is theta. Okay, so theta notation is theta of n of square, n to power 2. Okay, this is the theta notation. This is the average time between the upper bound and the lower bound, and it's calculated according to the average algorithms time taken